In this lesson, we're discussing properties of kites. I'm going to show you the properties that there are for kites. I have some sample problems that I'm going to do, and I have some problems that I would like for you to try on your own as well. So let's get started. So we have the properties for kites here. It is a quadrilateral that has exactly two pairs of consecutive congruent sides. And so we can see here AB and AD are congruent. So these are our consecutive sides here. They are congruent, as well as BC and DC. So these sides are congruent as well. It also has one pair of opposite angles that are congruent. And so the opposite angles that are congruent would be here. So ABC and ADC. So right here, these angles are congruent. And diagonals are perpendicular, so they intersect at that right angle. So AC is perpendicular to BD, so we can see that right here. All right. So now using that information, let's try some practice problems. Let's take a look at these two examples here. Our first example, we want to find the measure of angles B and D. Since kites are quadrilaterals, the interior angle measures the sum of the interior angles in a quadrilateral is always 360 degrees. Now, since I know that all angles together, angle A, B, C, and D would have to equal 360, I could find the measure of angles B and D because B and D would be congruent according to our properties given. All right. So I'm going to subtract 360 minus 85 minus 43. And that gives me 232. And then I simply divide by 2 because B and D would have to be congruent. So that gives me 116. So angle B is 116 and angle D is also 116 degrees. All right. Let's look at number 2 here. I like to fill in the figure before I actually fill in my lines here. So I know that these are all right angles, right? Because the diagonals are perpendicular. So this would be 90. Angle 3 would be 90. Then I can use my knowledge of the triangle angle sum theorem. So the interior angles of any triangle is always equal to 180. So taking a look at this triangle here, I can subtract 180. I know one of my angles is 52. The other angle is 90. And I subtract that. And I get 38. Alright, so I get 38 for that. So angle 6 would have to be 38. So angle 5 would also have to be 38 because this angle here would be 52 as well. Sorry, a little glitchy. Then I subtract 180 minus, this should be 52. 52 minus 90, I get 38 as well. Alright. Angles 4 and a 65-degree angle would also be, angle 4 would also be 65. If I subtract 180 minus 65 minus 90 for right here, I will get 25. So angle 1 is 25. Therefore, angle 2 would also be 25. Because they have the same angle measures in each triangle. So now I could just go back and plug in everything. Angle 1, we see here, is 25. Angle 2 is 25. Angle 3 is, of course, 90. Angle 4 is 65. Angle 5 is, where is angle 5? Angle 5 is 38. Angle 5 is right here. 38. Angle 6 is also 38. And angle 7 is 52. Right here. Alright, so let me put my degree marks here. And we found the measures of these angles. Alright, I have a problem here I would like for you to try on your own. So go ahead and pause the video and try this problem on your own, finding the angle measures. Alright, so hopefully you got the answers correct here. I forgot to put my degree symbol, so go ahead and check your answers. And if you did not get it correct, maybe pause the video and analyze my work here just a little more. Alright, so let's look at this problem here. It says Wx equals 14 and Wr equals 8. Find Rz. And we can actually make this little piece here a triangle XRW, to find the side length. This is perpendicular. Our diagonals are perpendicular, so right here we will have a right angle. And so since we have a right triangle here, we could use the Pythagorean theorem to find that missing side there. So remember, whenever you have a right triangle and you want to find the length of a third side and you're given two sides, you can always use the Pythagorean theorem. So remember, A and B are your legs and C is the hypotenuse. C is always opposite the right angle, or the hypotenuse is always opposite the right angle, and A and B are always your legs, and you can plug it in either way. So plugging this in here, I'm going to say a squared plus 8 squared is equal to 14 squared. And remember, you could plug in 8 here for a as well. It doesn't matter, you're going to get the same answer. I'm left with a squared plus 64. 14 squared is 196. Subtracting 64. A squared is equal to 132. Take the square root. And A is 11.5. So XR, which is A in this case, would be 11.5. And so I have found, well, no, we're asked to find RZ. So XR is 11.5. And so that would make RZ also 11.5. And there should have been a Z here. I don't know where it happened to it. But RZ would also be 11.5 as well, because they are congruent. Alright. So now let's take a look at, and they're congruent because if this is 8, just to make sure, our WZ would be 14. Okay, and they share a side length of 8, and so that is why they would be congruent. Okay, so let's try something else with this problem. It says if RY is 16, find the area of the kite. So just to add a piece here, if RY is 16, we want to find the area. I could actually separate this kite into two separate parts here. I could say, look at it as triangle WXY. And remember, the formula for area of a triangle is 1/2 base times height. So if I'm looking at triangle WXY, my base is 8 plus 16, so that would be 24. My height would be the 11.5, which is what I found. And so that would be 138. The other triangle would be the same, so I can multiply that by 2. So the area of this triangle is 276. There's no units here because I kind of just added this piece. But that is how you would find the area. And if you notice, it's really just, if you multiply your base and your height, you're going to get the same answer without taking a half. But just kind of break it down. You can separate it into two separate triangles, find the area of each triangle, and double it. Alright, so now let's try one on your own. Alright, so the last problem here I would like for you to try on your own. The added piece also, I would like for you to, so find CD. Then if EB is 6, find the area of the kite. So go ahead and pause this video and try it on your own. Hopefully you got the answer correct. CD is 45.2 using the Pythagorean theorem. And then that added piece there, if EB is 6, find the area of the kite. It should have been 893. And so those are your two answers. Hopefully you got them correct. I'm just adding this piece here. If not, go back and just pause the video. Well, not go back. Pause the video and analyze the work here a little bit more. All right, we've reached the end of our lesson. I want to thank you for learning with me. Some related videos are properties of parallelograms run by squares and rectangles. If you haven't already, please like, comment, share, and subscribe. And once again, I want to thank you for learning with me.